Here, is that better? Yeah. Uh, my 11-year-old sometimes plays games on my computer, and I think he accidentally muted my mic. So that's going to make for an exciting intro. Let me try that again. All right. Sorry about the technical hiccup. So today, what are we doing? I'll put it on screen as well. All right, make sure I got the right screen share on too. No, I'm on screen too. That's fine. Okay. So what are we doing today, class? What we are doing, feels like it's been forever. Okay. Things we are doing today include big words. Here we go. We're going to be doing systems of equations. And that means that we are going to be using today, at least, we're going to be using the substitution method. And some skills we're going to be using in the middle of that would include the distributive property and a lot of inverse operations. Yep. So I'm hoping what I put on Classroom made sense. If you want to get your questions for your assignments, you're going to have to watch the videos. You can either come watch them live and ask questions as we go, or you can watch the replay and get the questions that way. So today, everyone will have the chance to start working on their answer document on questions 1, 2, and 3. Hey, Cameron. So I'm going to answer a couple of emails that are coming in real quick, and we're going to get started here in just a second. Come on, guys. We'll start talking about skills here in, well, less than a minute, I guess. You guys better kill this timer before this siren goes off and annoys everybody that's watching or listening either now or later. Okay, so here's the plan. This week, instead of having a bunch of different skills, there's only one skill for every single problem you do. So you got 2 assignments, and they're both going to be all about the same thing, and that is called solving a system of equations using the distributive property. So before we actually get into what the problems are, we just need to discuss what in the world I'm talking about. So a system of equations is easy enough to understand. Make that straight as I can. Okay, so a system of equations is multiple lines in the same plane. That's really all it is. So just to clarify, I'm going to put that on the screen. But it doesn't need to be that large. Okay, so that's what a system of equation is. It's multiple lines in the same graph. And those lines can be going kind of anywhere. We'll put one there, and we'll put one right there. Okay, so there's our system of equations. Now, the solution to a system of equations, the way you solve them is you figure out where they cross. So right there. So there's our solution as it was. So the solution to a system of equations is where they cross. Now this is great when you are given a graph because you can just take your eyeball and look down here and say, okay, well, there's the X value, and look over here and there's the Y value, and just you're done. But this week, you are not going to have that luxury. You're not going to have a picture, just look at the X and Y. You're going to have to calculate it for yourself. And the way we're going to do that is called the substitution method. So for every single question, for every single moment of work you do this week, this is the one skill you're going to perfect. So here's how we're going to start. So paper and pencil ready. If you're not doing this on paper and pencil, you're hurting yourself because you're going to have to. All right, let me grab us a problem to do. One moment, I got an 8th grade message I got to answer because that's how it goes. Oh, you need to read the classroom assignment, sir. If you're asking where those questions are, you did not read the post. Dun dun dun. So let me get us our first problem for the week. Not the assignment problem, just our first practice problem. I guess I better put that on the screen before someone gets confused. Yep. If you're watching this on the replay, this is not a quiz question. This is not an assignment question. This is just practice. Okay. So here's our first attempt at solving a system of equation. What this is, these are our two lines. I just showed you a picture a minute ago of two lines that cross each other. Well, that's what this is. So sometimes when you see these written out, you will get a squiggle like this. You'll get a little bracket like this. When you see this bracket, that just means that these two equations are in the same graph. So what we are going to do is a series of steps to figure out the exact XY where they crisscross each other. And that'll be our solution. So here's what we're going to do. On your own paper, what you need to write down are these two equations, these two lines. So y equals 6x minus 11 and negative 2x minus 3y equals negative 7. Okay, so those are our two equations, and they are true, they are valid, they exist. So here's what we're going to do. We're going to take this part right here, because that's all equal to y, and we're going to substitute it in right here for this y. So here's what that looks like, and this is what you need to write down in your paper before we do any sort of actual math calculations. So you would have, once you substitute it in, you'd still have negative 2x. The negative 3 stays there, but then instead of a y, you put a parentheses in and put this whole bit right here that y is equal to 6x minus 11 end parentheses and finish out the line. So negative 2x minus 3, and then we put in the y, equals negative 7. Okay, so that is step one. You're setting up your problem right now. Speaking of setting up the problem, let's go and get our math practice standards on board. So we are making sense of our problem, and we're setting up some structure right now. Okay, so the next thing we've got to do in this particular problem, and pretty much all of these, the next thing you will do is the distributive property right here. We've got a negative 3 that needs to be multiplied by both terms. So we still have this negative 2x. That has not changed. Now, what is negative 3 times 6x? That would be negative 18x, because negative 3 times 6 is negative 18. Now, what is negative 3 times negative 11? Well, negative times negative makes positive. So negative 3 times negative 11 would be positive 33. And we still have an equal sign, and we still have negative 7. So we acknowledge that these two equations are in the same system. We've taken the value of y from one equation and substituted it into the other. And what this effectively does is now we don't have two variables. We only have one variable. So now our job is to solve for that one variable with inverse operations. So what we're doing now is we're going to be doing some abstract reasoning, and we're going to be doing very precise mathematics. The two main abstractions that we're going to be using right here, the abstract rules we're going to be using are that anything plus its opposite equals 0, and then anything divided by itself is equal to 1. Those are our two main abstractions that we're going to be abusing. So let's see how that would manifest itself here. Well, the first thing I noticed is that I can combine like terms, because negative 2x and negative 18x both have an x on them. So negative 2x, if you were at negative 2 and you subtracted 18, you'd be at negative 20, so that'd be negative 20x. I still have plus 33 equals negative 7. So the next thing I'm going to do, and this is my inverse operation, I'm going to be abusing this rule right here. If I subtract 33 from both sides, that would make it 0. So in our own vernacular, we say that cancels out. So we have negative 20x equals, now negative 7 minus 33 is negative 40. So now we'll use the other abstract rule. We'll be dividing by itself. So if we divide this side by negative 20 and divide this side by negative 20, here's what ends up happening. So negative 20 divided by negative 20 is 1. So we just end up with 1x. Negative 40 divided by negative 20. Well, negative divided by negative is positive. So we found out that x is equal to 2. That's half our answer, okay? Remember I said in my original little clip where I showed you the 2 lines that the solution was an xy coordinate. So now we've got half of that. We know the x value is 2. That's big. So we know, why did I write x? That's not what I wanted to say. So we know that part of the answer is 2. And now all we have to do is figure out what the y value is. So what we do is we go back to this original equation, y equals 6x minus 11, and we just take the 2 and jam it in right here at the x spot. So another use of substitution. So we're going to say that y equals 6 times 2 minus 11. We have to do the multiplication first, so that'd be y equals 12 minus 11, which means that y is equal to 1. So what we've just done is figured out where these 2 equations cross. The final answer for this entire system is that they crisscross at 2, 1. Okay? That is your entire week. If you get good at this, you will do really well on all your assignments. But if you notice, my scrap work here is pretty filled in. You've got to get really good at each individual step and not make little errors. So lastly, what are the things we've been doing? I constructed a viable argument by going back and doing this substitution to prove where everything fits in. I'm going to start using repeated reasoning on the next one. I like to think that our tools are our inverse operations, even though we don't have, like a protractor or anything. I'm being a little abstract with that. Yeah, I guess I did a lot of modeling with all my numbers, but that's the idea of it. Okay, question from chat. How did I get the 2? Okay, well, it started, kind of have to go back through the whole method. And we're going to do a bunch of these because this is the whole skill for the week. So it's not like I'm going to say, hey, good luck. Okay, so the 2 came from, if we backtrack it, step 1, let me get a different color. All right, so step 1 right here. We substituted in the value for y right here, where the y was. That was step 1. Step 2, we did the distributive property, and we did negative 3 times both terms. So now we've got negative 2 minus 18x plus 33, because that's what negative 3 would do if you multiplied it by 6x and negative 11, equals negative 7. Then we did some inverse operations because we wanted to get the x by itself. So we subtracted 33 from both sides, and then we divided negative 20 by both sides, and eventually we did get x by itself. And that's why I found out that x is equal to 2. I'm not sure what you meant by B. Sorry, I'm just trying to understand chat. And then what we did is we had to take that value. Once we get that, half the answer. Oh, I put a B. That's a 6. That's this 6. I took this equation right here. Yeah. Sorry, no, that's a 6. A poorly written 6. That's what that is. So I took this equation and I jammed the 2 we found out right there for the x value, and that just spits out our y value. So then we can put both of them in our answer. And it seems like a convoluted mess right there, but once you get the rhythm of this, they just fall in line, they snap together like Legos. Let's just try another one. So you watching at home, what you got to start doing is start pausing the video and trying them ahead of time. And then as I work it out, look at mine, look at yours, look at mine, look at yours, look at mine, look at yours, and see where our scrap work is the same, where it's different, and you can generate your own questions that way. So let's try another one. Okay, here we go. Again, these are just practice problems. This is not the quiz. I would say maybe in about 15 or 20 minutes, I'll post the actual assignment questions, but not yet. So let's try this one. Come here, I'm trying to move you. There it is. So let's try this one. And if that's hard to read at home, I'm going to write it down again anyway. So here's our system. These are the two lines, and I know they don't look like lines, but these are the equations that would make lines. And here's what they say. One of them says y equals negative 3x plus 5. And the other says 5x minus 4y equals negative 3. Yep, that's what they say. And sometimes when you see these, you might see a weird little bracket on the left side. What that is telling you is that these two equations exist in the same universe. They're in the same graph. So they are always going to be true statements. Okay? So this is where, if you feel comfortable after watching my last problem, you can start pausing it and working ahead of me. Now, if you're live, I'll give you a second to get started. But I'm going to see now the first goal is to take this right here, because it's all equal to y, and substituting it into this equation right here. So go ahead and try that, and then I'll show you what it should look like on your paper. Okay, so I'm still going to have 5x, but I'm going to have negative 4, and then in parentheses, and inside that parentheses, I'm going to put negative 3x plus 5. So 5x minus 4y, but in this case, the y is going to be this top equation up here. Negative 3x plus 5, or expression that is. What else is left? So I need equals negative 3. So for those of you counting, that's step 1. Step 1 is doing this substitution, okay? Now step 2 is doing the distributive property. So what we've got to do is take this negative 4 and multiply both of these terms. So that's our next step. So the 5x stays the same. Now negative 4 times a negative 3x. Negative times negative is positive, so that'd be 12x. Negative 4 times positive 5 is going to be negative 20. And now to have equals negative 3. So 5x, negative 4 times negative 3x is 12x. Negative 4 times positive 5 is negative 20 equals negative 3. Okay, so step 2 complete. We have done the distributive property. Step 3, combining like terms if you can. Now, I noticed there are some things we can combine, like this 5x and this 12x. They go together rather nicely. So 5x plus 12x, that'd be 17x. And we still have all this other stuff. We still have minus 20. equals -3. So 17x minus 20 equals -3. Okay. Now, the next step, step 4, is inverse operations. So in our inverse operations, we're going to make a 0 by adding 20 to both sides. Now, no one told me to do that, but my intuition tells me to because I've done these before. I want to get the variable x over on one side and then all the regular numbers, otherwise known as constants, over on the other side of the equation. So this is, again, this is an abstract rule that we were using before because these make 0. So what we're left over with, we still have this 17x equals 3. -3 plus 20 is -17. I'm sorry. No, that's not right. -3 plus 20 is just positive 17. So we're left with 17x equals 17. You might see what the answer is already. But if I divide both sides by 17, again, that's another abstract rule. Yep. So now, what's 17 divided by 17? X is equal to 1. Now that's only half our answer. So now what we do is we take that number and we go back to the very original problem and we jam it in right there and see what we get. So y equals -3 times this value, which is 1, because that's our x value, is 1, plus 5. So -3 times 1 is still -3. And then we add 5. So what is -3 plus 5? I believe the answer is 2. Yep. So now we have both x and y. So the answer for this, the place they crisscross, is at 1, 2. That's how it works. For those of you that are actually here, questions in the chat. Where'd this come from? Where'd that come from? Why do you have this there? That sort of stuff. You're the ones that are here. You're the ones that can ask questions. I'm hoping tomorrow we'll have a lot more once they realize what's going on.
Where'd you get 17x and -20?
Okay, cool. We'll backtrack up to number 2. Okay, so step 1, we rewrote the equation and we put in this for y. Step 2, we did the distributive property. We multiplied -4 times both terms. So -4 times a -3x is positive 12x, and -4 times positive 5 is -20. And that 17x came from right here where I combine these two things. These both have x's on them, so I have 5x plus 12x, and that's where 17x came from. The -20 has been here ever since I did the distributive property because -4 times positive 5 is -20. And we just kind of kept it along with us because we needed it all the way to solve all the problem. That sounded really strange. Yeah, we have it here and we have to use it. So that's why there was a -20 there, and that's where the 17x came from, is the addition of those two things. Okay. In chat, I want you to try and get an answer for this next one without me working it out, and we'll see how it goes. And then we'll consider putting the problems for the day up on the board. But there are going to be 3 of these, so if you have any questions, let's just clear them out. And I'm pretty sure, ooh, this would be, you know what? This one you might get not see how to do it right away, but I bet you can all do it. So this is a good one to get on screen, because this is slightly different from the ones we've just done. All right, so chat, let me see if you can notice what is different about this one from the two we've just done, or two or three we've just done. If you can't see it at home, here's what it says. It says negative 4x plus y equals 6. And then it says negative 5x minus y equals 21. Let me check that. Negative 4x plus y equals 6, and negative 5x plus y equals 21. Yep. So here's the question, chat. How are these two different from the problems we've already done? Anybody notice? In the last couple, when I've laid down the system, one of the two sentences just said y equals stuff. And in this one, you don't have that. Not yet. I should stress, not yet. So in a problem like this, you got one little extra step to do at the beginning. If you'll notice, we can do a little inverse operation really quickly and make this y equals stuff. If we just add on 4x to both sides of this equation, so that'd be negative 4x plus 4x. That cancels, that makes 0. Then you got y equals 6 plus 4x, but that's what we want. Now we've got y equals 4x plus 6. So that is the first mini step of this problem. My webcam is lagging out. Well, I apologize. I wish I knew why. My internet had a little bit of a glitch last night, but it's supposed to be working fine right now. Any better? Chad said that my webcam was lagging out, and I hope that is not the case. Yeesh. Okay, well, I'm hoping it's a little bit better. I'll try to slow down. So here's our first mini step. So what we had to do was we had to use an abstract rule right here. Math practice day number 2. We use that abstract rule of adding an inverse to cancel something out so that we would end up with just y equals stuff. And now we have the ability to take what y is equal to and jam it in for the y in the other equation. So here's what that would look like, and then I'm going to stop working and let you guys try it. So you'd end up with negative 5x minus the y value, which in this case is 4x. Okay, negative 5x minus 4x plus 6. I'm hoping I'm not lagging out anymore. Negative 5x minus 4x plus 6 equals 21. All right, there you go. So I'm going to give you guys a minute to try that. Let's see what you come up with. Go ahead and send me a private message in chat when you think you have the solution. And your solution will be an x value and a y value. That's what we're looking for, the place where they cross, if they cross at all. right, so I don't have. It doesn't look like I have any responses just yet. Maybe I'll get one in a second. So I'm going to start working this out, and you guys tell me at the end if we have something that looks the same. Okay, so we plug. So step one, we substituted. Well, step one in this case, we had to figure out what y was equal to. Step two, we actually put in the y. So now we have to do the distributive property. So whenever you have a negative symbol on the outside of these parentheses, that's the same as having a -1. So we got to distribute that times both terms on the inside. So I'll end up with -5x. -1 times 4x is -4x. -1 times +6 is -6. And then we just have them all equal to 21. Then I can combine like terms. 5x and I'm sorry, -5x and -4x makes -9x minus 6 equals 21. I can add 6 onto both sides. And I would end up with -9x. Now plus 6 minus 6, they cancel each other out. (21 plus 6 would be 27. Aha. So I run out of the room, but I think I can move everything. Hang on one second. Almost got everything. No. Undo that. I just want to move it. Okay. So -9x equals 27. So then I can, whoa. So then I can divide by -9 on both sides. And get, well, -9 divided by -9 is just 1. So I end up with just x. So -9 divided by -9 is 1. So I end up with 1x. And 27 divided by -9 is -3. So part of our answer is -3. That's the x value. Now to find the y value, I'm going to go back to our original right here and put a -3 in. I guess I could go ahead and use, you know what, I'm going to use this one right here. This x. So that would be y equals 4 times, and the x value found out is -3. Plus 6. So y equals 4x plus x. Y equals 4 times -3 plus 6, because we found out that x is equal to -3. Perfect. That means that y would equal -12 plus 6. So y, -12 plus 6 is -6. Let me put a nice box around that. So there's part of it, and there's part of it. There we go. So -3, -6 is where they crisscross. Okay? Last chance for questions before I put lesson 7 or assignment 7, problems 1, 2, and 3 on screen for everyone to try. Can't hear me. Well, I'm not muted. Can anyone else not hear me? Apparently, I've had all kinds of technical difficulties today with my mic. So, am I working? Yes or no? Okay. Weird. I don't know what happened. I wish I knew how long I've been talking before I couldn't be heard. That'd be nice to know where I could go back and say, oh, this is what I meant to say. Take a sip from a Diet Coke. Okay. So, questions. Does anyone have a question or need to see one more maybe before I go ahead and put up assignment 7 numbers 1, 2, and 3? Okay. Well, let's dig them out. So for those of you on YouTube that were just scrolling looking for your questions, here they come. I think it'd be amazing if you go back and actually look at all the work that I just did. But I know that is why most of you are going to be here, just like, where are my questions? Well, here they come. And just to make sure there's no confusion, so here's what everyone needs. So here's assignment 7 questions 1, 2, and 3. Okay. I just got to drag them on the screen for you guys in one moment. That's question 1. That's question 2. And that's question 3. Let me know if you guys can't see 1 because it's being covered up by our pictures. And there they are. So, your job right now, if you want to solve these correctly, let me see if I can give you some last minute tippos. So this is question 1, this is question 2, and this is question 3. And you'll notice on your answer document, you need to just give me the correct X and Y value. So what you're getting is the solution. You're trying to find out where these things crisscross. That's what you're doing. So just as a refresher. Might need to make this text a little bit smaller. 1 second. So step one is to make sure you have a variable isolated. So you have x equals stuff or y equals stuff. That was the step we got to skip on our first few practice problems. And then in the last one, we had to do a little work to make sure we had one ready for us. Substitute the value of your isolated variable into the other equation. So that's where you take whatever x is worth or whatever y is worth and you jam it into the other equation. Step 3, you want to make sure you use the distributive property correctly. So step 4, you're going to start using your inverse operations to figure out what your variable is worth. I guess I should note at this time you should have at this time you should have that's an important distinction. At this point, you should either have your x value or your y value. And then step 5 is where you go back to the beginning, you take the value you just found and substitute that in to your original sentence and then figure out what the other variable is worth. So then you use your inverse operation. You use your inverse operations again to get the other variable by itself. Okay, so that sort of concludes the end of today's lesson. We did some practice problems on how to use the substitution method to answer systems of equations. These are the first 3 problems of assignment 7. Tomorrow, I'm going to do more practice problems, and you will get the questions for 4, 5, and 6. And we will rinse, repeat this skill throughout the week to make sure that everyone understands how it works. And that is your job by the end of this week, to be a master of using the substitution method to solve systems of equations. Yeah, just to recap, the only way you're going to see these questions is to actually log in to either the Zoom session and see it live. But if you can't make it because of reasons, I understand. Just watch it on YouTube after, which I'm sure all of you are doing. I posted some information on Classroom where I showed you guys that despite how many hours of content I'm putting out for you guys to watch, really almost nobody's watching it. I'm averaging like 13 views, and some of those are my own clicks, just to make sure it worked right or posted correctly or something. So what I take away from that is that most of you are just electing to try and teach yourselves, and that's just not fair. You need to be watching me do these problems, or worse yet, because of the 46 people I think that are flunking, a lot of you are just resigning yourself to guessing or just not doing the work. So please join us on Zoom so you can ask questions. Since we're doing the same skill all week, feel free to bring your questions with you, screenshots if needed. And, we're going to work this out. We are going to figure this out. So unless Chad has any last minute questions.
Can you send me my grade for your class?
I think we're going to have to do the corrections a little bit differently. Like, How about this? If tomorrow during my stream you want to ask me like privately, hey, these are the answers I got for 1, 2, and 3, we can just do corrections as we go. How about that? Yeah. I think it's a more natural flow. Like what I've found, it takes an inordinate amount of time to go through all those papers and grade them once and send them back and then to do them again. And what I've noticed is this: for all the people that turn their stuff in early to get corrections, the number of people that actually go back and try them again is like 3. Almost nobody goes back and tries those problems again for their own reasons. Maybe they feel like, well, I got a 60 and that's good enough, or maybe they just could care less. Like, I got a grade. It's not a 0, so whatevs. So I think it'd be more natural just to do this every day. Say, hey, listen, if you want to check your answers from yesterday, yeah, I guess I gotta find a way the best way to do that. Chat, if you want to know your grade, just email me. That's like the most efficient way. That was one of the emails at the beginning of the stream when my mic may or may not have been working. And sorry, I just got an email from another teacher. So yeah, so I would rather just do it day in, day out. Like tomorrow we log in, and I'll say, hey, if anyone has answers for problems 1, 2, and 3 and they want me to give you feedback, send me a private message now, something like that. Unless you just want to send me an email before tomorrow, in which case I will respond. And that way you can just fix your answers as we go, and then I grade it once and everyone's done and happy. Okay. Question before I go. These questions I posted, can you guys read them? Are they big enough? I don't want to have people tell me later that no, they're too small. Great. Okay. Well, if anyone at home says they can't be read, too bad, because chat said that they could be seen. So there it is. Okay, guys. I'll see you tomorrow with questions 4, 5, and 6 on using the substitution method to solve systems of equations. Take it easy.